Now, listen carefully and answer questions 31 to 40.
Today, I'd like to explore the concept of soundscapes, a term that refers to the acoustic environment we live in essentially. The sounds that surround us in any given setting, whether natural or human-made. The term soundscape was first introduced by Murray Schafer, a well-known composer from Canada, who devoted much of his career to understanding how sound shapes our experience of the world. He argued that what we hear is not just random noise, but something that carries meaning, often reflecting the character or even the health of the environment we're in. Schafer and those who followed his work divided the soundscape into three primary components. The first is biophony, which includes all the sounds produced by living creatures. For instance, birdsong, insects buzzing, and the croaking of frogs all fall under this category. The second category is geophony. This refers to natural sounds that arise from non-living elements of the environment. Examples here include the rustling of leaves, wind blowing through trees, or the steady patter of rain. These are physical phenomena that still form an important part of what we hear in nature. Finally, we have anthrophony. This encompasses all human-generated sounds, whether intentional like music or unintentional, such as engine noise, construction activity, or even general urban clatter. One of the key researchers in the modern study of soundscapes is Bernie Krause. Krause has spent decades recording natural soundscapes and has reached some fascinating conclusions. According to him, every sound in the natural world carries its own distinctive signature, a kind of auditory fingerprint. More than that, he's found that, when undisturbed, the sounds of nature demonstrate a delicate balance. They are generally in harmony with each other, especially in terms of loudness and frequency, which prevents them from clashing or overwhelming one another. Interestingly, shifts in a natural soundscape can tell us a great deal. In fact, changes in what we hear may be an early sign of larger environmental problems. For example, a sudden decrease in certain animal calls may point to alterations in the climate of that region. Similarly, irregular patterns in sound can also be a signal of pollution, not just noise pollution, but chemical contamination as well, such as the use of pesticides or insecticides, which can cause entire species to fall silent. To capture and analyze these complex sound environments, researchers today often use sophisticated tools like acoustic recorders. These devices collect audio data over extended periods, which can then be visualized into three-dimensional maps. Such maps help scientists to study sound patterns across space and time,